Okay, brothers, let's have another example. This time the example is about the discrete time signal, and if you notice that I have only a single sinusoidal signal. Okay, it's not the addition of the multiple sinusoidal signal. So first of all, uh, to find if the signal is periodic and non-periodic, it's like a bit tricky in case of the discrete time signal. Okay, the main reason is in case of the discrete time signal, we know that the axis is always like the value of small n. Okay, the axis along so all the time you can say n is always the integer value. I cannot have a non-integer value here. So I mean, in most of the sinusoidals, there is a general condition. We will check for the condition. If the condition satisfies, we say it's periodic. Otherwise, it is non-periodic. So let's suppose first of all, we will compare it with the general form. So in this case, obviously, like it will be cosine omega n here. Okay. So from here we can easily find what is our omega. So omega will be equal to basically omega is equal to 2 pi um, 2 pi over 12 here, which is basically equal to pi by 6 here. Okay, pi by 6. Now we found the value of the omega here. Now if a given signal is periodic or non-periodic, the condition will be the condition is we should compare like omega or omega 1 divided by the 2 pi should be equal to k by n here. Okay. Now we assume that this ratio k by n, this should give me a rational number here. Rational number. So basically, like we are interested in finding the ratio of k divided by n by dividing omega with the 2 pi. If I end up with the rational part here, means the omega by 2 pi value is some rational number, then we will say that the given discrete time signal is a periodic signal here. How we got this particular condition here, I mean, there is a proof from the general form. I think we should have done that thing in the theoretical part maybe. Okay, so I'm just using that result directly to solve it. So let's suppose we are interested in finding the k by n ratio here. So omega will be equal to k divided by n will be equal to omega, which we got is pi over 6, and then we are going to divide it with the 2 pi here, so which we will end up with pi will be cancelled with each other here, so we will get 1 over 12 here. Okay, so k divided by n is equal to 1 over 12. Now this is the ratio of two integers, so we said that this is a rational number here. So if it is a rational number, we said that the given signal x of n is bracket, okay, please, is periodic signal. So if it is a periodic, we can find the fundamental period, and obviously this n is basically your fundamental period. So you can say it's basically n equal to 12 here. So you can find the fundamental period directly here. Or another way is basically we say that let's suppose just from the same thing, k by n is equal to 1 over 12. So from here we will have basically n, we are going to find the value, okay, from n. So n will be equal to 12 k here. Okay, now I did not explain a lot, but I mean this in this case, this is a ratio of two integers here. Okay, this is the ratio of two integers here, so it means that the value of k is again some integer value. Now what is the importance of this k? The importance of this k means the value of k, we will choose the smallest value of k such that our n become an integer here. Now if I put k equal to 1 here, obviously the smallest value of k is 1. So for k equal to 1, so for k equal to 1, n will be equal to 12. So this is my fundamental period here. Okay, clear? Just a small explanation more, I mean, about this, clarifying here. Sometime, for example, in this particular situation, okay, sometime you may end up something like this. Okay, I'm not sure, but I'm just giving you the example. For example, you get n equal to maybe like 2 by 3 k here, for example. Now in this case, if you want to get the integer value of n, because we are talking about the discrete time signal, so my fundamental period should also be integer value. Okay, I mean, it depends, it is the number of samples in that case. So the number of samples cannot be in the points, it will be the complete samples here. So the smallest value of k, which will give me integer value here, is obviously when I put k equal to 1, so I will get 2 divided by 3. So this is not an integer value. So it means that if I put k equal to 2, I will get 1 over 3. Again, no. If I put k equal to 3, then I will get n equal to 2. So in this case, we will say that for k equal to 2, n is equal to, for k equal to 3, n will be equal to 2, and this will be your fundamental period in this case. Okay. So I mean, this is the importance of k basically in this part. Clear, brothers? So thank you.